Okay, so I realized that I always started standing this way, so I'm trying to stand straight this time. So, in the last video, what you learned was you learned to determine if a reaction is balanced or unbalanced. You would count out the atoms on each side and then say, oh, yep, that one's equal to that one's equal to that one. Oh, that's not equal. This one's 2 chlorines and 1 chlorine, so it's unbalanced. It does not obey the law. Now you're going to learn how to actually fix that. And so I'm on page 12 and 13 in your course pack, and this is called Balancing Chemical Equations 5.5 and 5.6. The reason why we split this into 2 lessons is because one is when we're balancing simple compounds, and then the other one is when we use those polyatomic ions and things get a little bit more complicated. So today we're just going to focus on 5.5. Your math skills, if you look through it, the first step, find the biggest, the ugliest molecule out there. That's going to be called your lead molecule. Most likely, it's the one that's got the biggest numbers or the most atoms, and you'll kind of get the hang of it as we do these practice ones. You're going to balance all the atoms in the lead molecule first. Once you've done that, you're going to balance all the atoms in the rest of the equation. And then finally, and this rarely happens, but it does, if the balanced equation is non-whole numbers, you're just going to double it. You're going to double every coefficient. Now, remember, just to recap, I can never change the subscripts. I can't say, oh, I need 2 more oxygen, so I'm going to change this to a 4. No, 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 no. You cannot do that. The only thing you can do is you can change the coefficients. That's why if you look ahead in your course pack, all of the course pack problems have blanks. I cannot go ahead and change any of the subscripts. I can only change what goes out in front. So, let's go ahead and do an example. Methane and oxygen make carbon dioxide and H2, and this should be H2O. Alright, so I'm going to do the same steps. I'm going to write down all my species. So I've got C, H, and O. C, H, O. Okay? And I've got C, H, O. Notice I always write them in the same order. And I'm going to count how many I have in each. I've got 1 carbon right now, 4 hydrogen, 2 oxygen. 1 carbon, 2 oxygen here, and a 3rd oxygen there, and 2 hydrogen. Well, clearly this does not obey the law, so I'm going to have to balance it. These are unbalanced. So, pick the ugliest molecule. I'm just going to start with this one. It's typically the first one, so that works out for me. So I'm going to pick CH4. I think he's the ugliest. My C's, they're already balanced. Done. My H's, 4 here, and there are 2 here. Well, this is a problem. I got to bring this guy up to 4 so he is balanced. So what I do is I find H. Oh, H is here. And since it's H2, if I want 4, what I can do is I can add a 2. Now remember, if I put a 2 out front, I multiply that 2 by each one. So now I've got 2 times 2, I've got 4 hydrogens, but be careful, I change my oxygen as well. 2 times 1 oxygen gives me 2 oxygen, not to mention the 2 oxygen I have here. So now I've got 2 plus 2 gives me 4 oxygen. I'll come back over. H's, 4, 4, balanced. Oxygen, 2, 4. Well, this one's easy. There's 2 oxygens here. I need 4 of them. Put a 2 out front. 2 times 2 gives me 4 oxygens. 1, 4, 4, 1, 4, 4, balanced. And for now, although you don't have to do this, this means 1 methane molecule. This means 2 oxygens, 1. I'm going to have you put the 1s in now, just so you can, as you're going through. Okay, let's go ahead and do another example. Sodium chloride dissolves into sodium solid and chlorine gas. We'll call this gas. And first step, list out your elements. NaCl on this side, NaCl on this side. Okay, well I've got 1, 1, and I've got 1, and I've got 2. Okay, well if I've got 2 here and 1 here, I just got to change chlorine, so why don't I just add a 2 to chlorine? Good? No. Hopefully some of you are shaking your heads. I cannot change a subscript. Remember, the only thing I can change are the coefficients, the numbers in front of the compound. So this is a no-go. That's cheating. Cannot do that. Does not work. So we're going to have to find a new way. Well, we've got 1 here, and I need 2 chlorines. Sodiums are already balanced. I need 2 chlorines. Well, I could just double this whole thing in front. I'll use my color. 2, which gives me 2 chlorines, 2 times 1 chlorines, but it also gives me 2 sodiums, 2 NAs. So now I got a problem. I just balanced my chlorines, but now I messed up, and my sodiums aren't balanced. Well, that's a quick fix. 1 Na, 2 Na. I can just put a 2 out here. Now I've got 2 Na. Check, check. 1, and done. Okay. Let's check out another one. Hydrogen gas plus oxygen gas, a couple Brinkelhoff gases, make water. List out the elements. H, O, H, O. What do I got? Well, I've got 2 hydrogens, and I've got 2 oxygens. I've got 2 hydrogens and 1 oxygen. Well, what am I going to balance first? Looks like my hydrogens are already balanced, so I'm going to focus on the oxygen. This is 2. I need 2 over here. Remember, I can't add 2. I can only change the coefficient. So I'm going to put I'll change to blue right now. Put a 2 right there, but not only does that change my oxygen to 2 times 1, which is now 2, which is good, but it changes my hydrogen to 2 times 2 now has 4. So I've got 2 oxygen balanced. Now I got to go up to hydrogen. 2 hydrogens here, 4 here, which means I got to double this. If I put a 2, 2 times 2 gives me 4 hydrogens. Check, 4, 2. 4, 2, check, check, 2. And you remember you put a 1 where any left open blank spaces. So, kind of tricky at first. I had to go back and actually balance this one first. Okay, I think we're down at the bottom of page 10 now. Oh, 12, excuse me. Oh, word problem. We've done this before. We did this lesson 5.4, writing equations from words. Now, you're going to have to pull from your Unit 4 background here, but I know you guys are up for the task. We've got carbon disulfide, and it's a liquid. Well, carbon, I know that, and disulfide, this is a covalent compound. You know how I know that? Covalent compounds. Oh yeah, that is 2 or more nonmetals, which means they use the naming convention mono, di, tri. So it's easy. Carbon is 1, because it's not, never put monocarbon, right? You never say mono for the first one. Carbon is 1. Di means dos, 2, deuces. CS2, liquid, and I realize I'm writing in blue now, hopefully that you can see that, reacts with plus. Reacts with plus. And oxygen. I know that's O. That looks weird though. Brinkelhoff. Oxygen gas. Got it. So, and I'm going to leave blanks here. I'm going to leave blanks so I can balance it in a second. Get so you can really see that plus. There we go. Okay. Producing. Ooh, that's new. But it sounds like makes. Sounds like forms, yields. That's right. Talking an arrow. Carbon dioxide. We've seen that so many times. Carbon dioxide gas, CO2. Should be in your memory by now. And sulfur dioxide. Well, we know S. Sulfur and dioxide mean 2 oxygens. And it's a gas, so I put a little G to represent gas. So, I've written my equation, which is half the battle. Now I've got to see if it obeys the law of conservation of mass or not, if it's balanced. Let's go through and do it. I'll do it in a different color now. Carbon, sulfur, oxygen. Carbon, C, oxygen, sulfur, and oxygen. Okay, well, let's count up how well we got. We've got carbon as 1, and we got sulfur, 2 of them, and 2 oxygens. Okay, come over here, we got 1 carbon, 1 sulfur, 2 and 2 gives me 4 oxygens. So if I look at, is anything balanced? Yeah, carbon's balanced, sulfur's not, and oxygen's not. So I'm trying to pick the ugly one first. I'm going to start with CS2. I'm going to try and balance my sulfurs first. Well, I've got, let's see, use purple. 2 sulfurs, 1 sulfur. I can't go down. I can never like divide by 2. I would never do that. So I'm going to have to come over here and try and get this to be 2. Well, I can do that by putting a 2 out front, which gives me 2, but it also makes my oxygens change. So 2 times 2 oxygens gives me 4 oxygens, plus the 2 I already have, which makes this 6. Okay, let's come back. Okay, I'm making my way. I've got carbon and sulfur balance, but my oxygens are messed up. Ah! 6 oxygens, 2 oxygens. The only oxygen spot's here, so I can just put what times 2 gives me 6? 3. 3 times 2 gives me 6 oxygens, and that's 7. And remember, we like to add our 1s. Okay, that's a pretty complicated one. One more before I turn you loose to do practice, and you've actually got a homework assignment in the back of your course pack to work on for the rest of class. So, and this one's kind of tricky. CHO. CHO. Okay. And if you guys are confused when I'm doing this, realizing that I've done this a lot, and the only way to get good at this is to practice it. So if you're having trouble, I'll post this on YouTube. It'll be on the site as well. Look it up. Pause me. Go through it. Trust me, I've been doing this for a while. This is why I'm good at this, and you'll be good at this after we practiced it. 3, 6, 2, 1. I realize I did that fast. 3 carbons, 6 hydrogens, 2 oxygens. 1 carbon, 2 hydrogens, 2 oxygens, 1 oxygen, 3 oxygens. Okay, so now we got to balance this. Well, I'm thinking this is the ugly guy. C3H6, he's got the big numbers, so I'm going to mess with him first. Always pick on the ugly guy. No, just kidding. Be friendly. Probably smarter than you. That was probably inappropriate for